Hello, and welcome to Compound Interest. My name's Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. Let's talk about compound interest and start with a definition. The future value of an investment of PV dollars earning interest at an annual rate of R compounded, also known as reinvested, M times per year for a period of T years is FV equals PV times 1 plus I to the N power, where I is R over M and N equals M times T. Similarly to what we did for simple interest, we can divide both sides by the amount here in parentheses along with its exponent to isolate and get PV by itself. PV equals a future value divided by 1 plus I to the N. Now, if possible, always find I and N first. If I is an ugly decimal, 0.04 divided by 12, you're going to have to round it. You're going to have to decide where to stop. Use the fraction in the formula for a more exact result. I'll always find my N value, number of compounding periods per year, multiplying by the number of years. But the I might leave in fraction form. Here we go. Let's calculate the future value of an investment of $8,000 at 4% per year, compounded semi-annually for 8 years. And then we'll also determine by how much this investment has grown. Same as with simple interest. $8,000, the amount that we are investing, is our present value. 4% written as a decimal is 0.04. As soon as we see the word compounded, we know we're using the compound interest formula, and semi-annually tells us how often. Semi-annually happens twice a year, so our M value is 2. And T equals 8 years as given in the problem. I'm going to find my I, 0.04 over 2, which simplifies to 0.02. And I'm going to find my N value, semi-annually for 8 years, so twice a year for 8 years, it compounds a total of 16 times. Using my formula, future value equals PV, 8,000, parentheses, 1 plus I, so 1 plus 0.02, close parentheses to the power of N, so to the power of 16, and I'm going to put this entire thing in my calculator and let it all take it. It'll do the calculation for you. You don't have to do it step by step. All calculators can do this. $10,982.29. Now keep in mind, we invested $8,000. We now have $10,982.29. We have the amount the investment has grown by is future value minus the present value. Oops, not that. Minus the present value equals the total amount of interest earned. Keep in mind INT was a value that we used for simple interest, but if we use it for interest in general, the same is true. The amount we have in the future minus what we started with will always be the amount of interest that we've earned. Let's calculate the future value of an investment of $16,000 at 2.5% per year, compounded quarterly for 5 years. So my present value of $16,000 are 2.5% in decimal form, 0.025. Compounded tells us the type of formula. Quarterly tells us it happens 4 times per year. And T value is given by 5 years. I can find my I, 0.025 divided by 4, which is 0.00625. And I'm going to use the entire decimal. I'm not going to stop it early. I'm not going to round. I'm not going to change it. I'm going to use the full decimal every time. N, quarterly for 5 years, will be a total of 20 times. So my future value is 16,000 times, in parentheses, 1 plus 0.00625, close parentheses, that's 1 plus I, to the power of N, 20. And entering that in a calculator, you will not want to try and do that by hand. I'm just saying. $18,123.32. From the original $16,000 we invested, that means my investment has grown by $2,123.32. Subtracting future value minus present value to get the amount the investment has grown by. If we're investing $50,000 at 1.5% per year, compounded weekly for 5 years, then we identify our variables, PV equals 50,000, R and decimal form 0.015. Weekly happens 52 times a year according to our Gregorian calendar, and the time given is 5 years. When you try to find your I value, 0.015 divided by 52. This is what I meant by an ugly decimal. It's long, nobody wants to deal with that. It's way too long for you to want to keep writing over and over again, so we'll just leave it as a fraction. But 52 times a year for 5 years, 260 times that this will compound. So let's see. My future value is 50,000, parentheses, 1 plus 0.015 over 52, because your calculator can handle fractions a lot more quickly and probably easier than you can, so we'll just leave the fraction. Close the parentheses to the power of 260, and after 5 years I'll have the $53,893.62, and again subtract the original 50,000 to find how much the investment has grown by. Now let's calculate some present values. We'll calculate the present value of an investment that will be worth the given amount at the stated interest rate after the stated amount of time. So it will be worth $7,000 after 10 years at 5% per year compounded monthly. The 5% per year is 0.05. Compounded monthly tells me I'm going to divide by 12. My end value is monthly for 10 years, so 12 times 10 to get 120. We want to find present value here, so now we're going to use division. We'll have future value 7,000 divided by, in parentheses, 1 plus I, and I left it as the fraction because the calculator can handle it. Close parentheses to the power of n. Hit equals, make sure you use these parentheses, and we'll get $4,250.13 needs to be invested now, so that in 10 years we could have $7,000. Tip for you, this is not the best way to save money, but we'll talk about that later. Calculate the present value of an investment that will be worth $12,500 after 5 years at 7% per year compounded daily. Okay, my interest rate, 0.07 per year daily, so 0.07 divided by 365. Let me just stutter over that a little while. The number of compounding periods total, 365 for daily for 5 years. That's 1,825 total compounding periods. The present value will be 12,500 that we want in the future, divided by 1 plus I, close parentheses, to the power of n, 1825. Hit enter on the calculator, let it handle it all at once. That's $8,808.90. Effective annual interest rate, R sub EFF, of an investment paying a nominal interest rate, R nom, compounded m times per year is given by this formula. RF, so the effective rate, is 1 plus the nominal interest rate divided by m, all raised to the m power minus 1. Notice this is 1 plus I to the m, not to the n, but to the m. What an effective annual interest rate does is let us put everything, whether it's compounded 5% compounded monthly, or 4.7% compounded weekly, or 4.8% compounded daily, it puts it all into effectively as an annual interest rate, so we can compare them, because different compounding periods and different interest rates will give us different values. So we put them all into an annual interest rate, an effective annual interest rate, and we can compare the different values to see what's going to be a better deal. So if I have 5% compounded quarterly, the effective annual interest rate will be 1 plus 0.05 over 4 to the power of 4 minus 1. My calculator displays 0.0509, which I'll round to 5.1%. 5% compounded monthly. That'll be 1 plus 0.05 divided by 12 to the power of 12 minus 1, which gives me 0.0512, also rounds to 5.1%. What this tells me is a 5% compounded quarterly and a 5% compounded monthly, those two accounts, are essentially the same as 5.1% compounded annually. That way I could compare. 9% compounded monthly, 1 plus 0.09 divided by 12 to the power of 12, minus 1, gives me 0.0938, so we'll call that a 9.4%. As you're doing your homework, pay attention to the details and what's the problem asking for. Is it asking for you to round to 1 decimal place percentage? Maybe it's asking you to round to 2 decimal places for the percentage. Alright, pay attention. If you're using WebAssign like we do at UTEP, make sure I think it's a 2 decimal place, which is not what I used here in this example. Compounded interest. Compound interest formulas. Pay attention to the words that tell you what your M value will be. That's it for now. Thanks for listening.